Hello everyone. This video lecture I will going to discuss about fuel topic. The contents of this video: general introduction of fuels, classification, calorific value, and determination of calorific value using bomb calorimeter, and theoretical determination of calorific value by using Dulongs formula, and one of the example. Now let me first I'll give introduction about fuels. Fuel is any combustible substance which on combustion produce a large amount of heat which can be used for various domestic purpose as well as industrial purpose. In most of the fuel generally mean used to contain carbon as the main constituent, and some of the common fuels are, we already know that one: wood, charcoal, kerosene, diesel, and producer gas, biodiesel gas, etc. etc. Among that, fossil fuels are non-renewable energy resources which were stored up millions of years ago by photosynthesis. The fossil fuels are coal, crude oil, crude gas, natural gas, biogas, etc. etc. The process of combustion involves oxidation of carbon, hydrogen, etc. etc. Means the oxidation of any element is called combustion. Of fuels, the product of the combustion is carbon dioxide and water, and the difference in the energy of reactants and products are liberated as large amount of heat which is utilized for domestic as well as industrial purpose. Means the difference in energy of reactant and product is called liberation heat. In that fuels general classification, next we'll move for general classification. Fuels which can classified by various types based on their origin as well as nature. Importantly, fuels which can be classified into two types. One is natural fuels, other one is synthetic fuel, means derived fuels. Natural fuels means which are obtained by naturally. This further it can be classified into three types: solid, liquid, gases. This classification is based on the nature of the fuel. Solid is an example of the natural fuel: wood, coal, dung. Liquid fuel example: crude oil. Gaseous fuel example: natural gases. These fuels which are obtained by its nature, it is not prepared by man-made. The next one is derived fuel. It's nothing but synthetic fuel. The synthetic fuel is nothing but the fuels which are obtained by primary fuels, means natural fuels, which are man-made fuels. These are further classified into three types. One is solid, liquid, gaseous. These three classifications is also based on their nature. Solid fuel example: coke, charcoal, petroleum, coke, coal, briquette. Liquid fuels example: tar, kerosene, diesel, petrol, fuel oil, LPG gas, LPG liquid, synthetic gasolines. Gaseous fuels example: the nature which is in gases: coal gas, water gas, oil gas, biogas, coke oven gas, blast furnace gas. These are the general classification of fuels. Then what are the good characteristics of fuel? Means which fuel is a good fuel? Generally, the good fuel characteristic is based on their calorific value. Means very good fuel means the calorific value is very high. Next, the fuel, second point, the fuel must not produce harmful gases. Third point, the fuel should moderate ignite temperature. Fourth point, easy to transport. Fifth point, less amount of sulfur content in the fuel. Means very good fuel means the fuel, it should have high calorific value, and it should less production of smoky flame, ash, and it should moderate ignition temperature. It should be non-volatile. It should be easily transportable. Means the various characteristics of fuel, various good characteristics of fuel we can explain based on their nature, based on their origin. Next, one of the important topic is calorific value. Means the fuel characteristic which can be assessed by its calorific value. First, what is calorific value? There are different expressions for calorific value. Among that, the first one is in that calorific value means the amount. First, the calorific value means the amount of heat is liberated by its combustion of 1 unit mass of fuel is completely burnt with oxygen. It's called calorific value. In that calorific value, there are two types of calorific value. One is net calorific value, is nothing but lower calorific value. Other one is gross calorific value, means higher calorific value. Higher calorific value or gross calorific value is nothing but the quantity of heat is evolved by its combustion of 1 unit quantity of fuels is completely burnt with oxygen, is called gross calorific value. Net calorific value or lower calorific value is nothing but the amount of heat is produced by a 1 unit volume or 1 unit mass of fuels is completely burnt with oxygen. And the product of the combustion is allowed to escape, is called lower calorific value. Means the difference is the net calorific value to gross calorific value is the net calorific value is higher calorific value minus latent heat of water vapor. Higher calorific value minus latent heat of water vapor. Higher calorific value minus latent heat of water vapor formed. Means the latent heat of water vapor formed means the mass of hydrogen into the mass of hydrogen parts by its mass of water into latent heat of steam. Means 0.07% of hydrogen. Means higher calorific value, gross calorific value means the amount of heat is produced by when a unit mass or unit volume of fuel is completely burned with oxygen, and the product of the combustion is allowed to cool down to room temperature. But lower calorific value, the product of the combustion is allowed to escape. Only this difference. The calorific value of solid and liquid fuel, it can be determined by using bomb calorimeter experiment. The next topic is determination of calorific value by its bomb calorimeter. The general principle of bomb calorimeter is to determination of calorific value of solid and liquid fuel means a known amount of solid and liquid fuel is taken in a bomb calorimeter, and the amount of heat is produced by a known amount of fuel is completely burnt. The heat is transferred to a known amount of water, The rise in temperature is determined by using bomb calorimeter principle. Is the principle of bomb calorimeter experiment. In this, the bomb calorimeter apparatus, which is used to determine the calorific value of solid as well as liquid fuel, is known as bomb calorimeter. What is bomb calorimeter? Bomb calorimeter is used to determine the calorific value of solid and liquid fuels. Okay, in this diagram, it contains in this diagram is bomb calorimeter. This apparatus consists of a cylindrical stainless steel bomb, the lid of which is screwed to the body to make it airtight. Next, through the lid there is one oxygen inlet valve and two electrodes. Right, sorry. These two electrodes. In the bomb, there is a nickel crucible attached to the ring. This is nickel crucible attached to the ring. The sample of the fuel is placed in the silica crucible. An electrically heated magnesium wire touches the sample. This magnesium fuse wire touches the fuel sample. The bomb is placed in a copper calorimeter. Bomb is placed in a copper calorimeter, which is surrounded by air jacket and water jacket, which minimize the heat loss due to radiation. This air jacket and water jacket. There is a stirrer and Beckman thermometer which can accurately measure the temperature. This is up to n by 100th of degree. Next, a weighed mass of fuel is placed in the crucible, is allowed to burn in oxygen by electrically spark across the electrode, and heat is evolved across the electrode, and the heat is liberated here is measured by the principle of calorimeter. That is, heat liberated is taken by calorimeter water. This calorimeter water, heat is liberated is taken by calorimeter and water. The initial and final temperature of the calorimeter is noted with the help of Beckman calorimeter, means T1 and T2. Next, here the weight of mass of fuel taken is noted, that is small m. Weight of water taken inside the calorimeter is capital W. Water equivalent of calorimeter, small w. T1 is the initial temperature, T2 is the final temperature of the calorific value. Means HCV is equal to gross calorific value of fuel. Is it? Means next, L is nothing but here L is equal to HCV is equal to capital W plus small w, T2 minus T1 divided by m calorie per gram. Small w represents mass of fuel, capital W represents mass of water in calorimeter. Capital W represents mass of water in the calorimeter. Small w represents mass of water equivalent calorimeter. T1 is the initial temperature, T2 is the final temperature of the calorimeter. M is nothing but mass of the fuel. Here, the water equivalent of calorimeter is determined by burning a fuel of known calorific value and using the above equation. The fuel used in the above purpose are benzoic acid. Its gross calorific value is 6325 kilocalorie per gram, and naphthalene. The correction factor is used to get the accurate results included. These three correction is used to calculate the accurate value of calorific value, because the amount of heat is liberated is not equal to the amount of heat is absorbed by the water containing copper calorimeter, because some of the water is absorbed by calorimeter and electrode, and some of the apparatus containing the copper calorimeter. That's why corrections is highly required to calculate the calorific value of the respective fuel. So the first correction is fuse wire correction. This fuse wire correction is heat liberated during sparking should be subtracted from heat liberated. Means the fuse wire which are used to ignite the fuel sample, this fuse wire is also, it will produce some amount of heat. That's why the amount of heat is liberated by the fuse wire, it should be subtracted from the higher calorific value. Second one is acid correction. This acid correction means if the acid correction is nothing but if the fuel sample contains sulfur and nitrogen, if the sulfur and nitrogen, if it is oxidized, it will form sulfuric acid as well as nitric acid. When the formation of sulfuric acid and nitric acid is an exothermic reaction, means as the acid formation or as exothermic reaction means it will produce some amount of heat. This heat is also, it will included in the higher calorific value. This same amount of heat liberated by the formation of acid, it should be subtracted from the higher calorific value, so that this acid correction is also required. Next, third one is cooling correction. The rate of cooling of the calorimeter from the maximum temperature to room temperature is noticed. From this rate of cooling and the actual time taken for cooling, then correction is called cooling correction and is added to T2 minus T1 term, because in order to increase the temperature, observed temperature, in order to increase the observed temperature, this cooling correction is required. Therefore, L is nothing but higher calorific value is equal to capital W plus small w T2 minus T1 plus cooling correction minus acid plus fuse wire correction, plus if cotton is used, that cotton correction which also included. Means if some of that material which are used, that material is also combustible substance, at that time that correction is also added in that acid plus fuse wire correction plus cotton correction, etc., etc., divided by m. M is nothing but mass of the fuel taken. This is higher calorific value. Lower calorific value, we already know that one. Lower calorific value is equal to NCV is equal to HCV minus mass of hydrogen into A into latent heat of steam. This is that experimental calculation of calorific value, of the particular solid as well as liquid fuel. Next, we can also calculate the calorific value of fuel if the constituent amount if it is known. Means if the particular fuel in a particular fuel, the constituent present in that fuel if it is known, we can able to calculate the calorific value of that fuel by using Dulongs formula. In this formula, very simple formula. In this formula, it contains HCV is equal to, in this formula, calorific HCV is equal to 1 divided by 100, 8080 into C plus 3450 into H minus oxygen divided by 8 plus 2240 into S kilocalorie per gram. Then this formula was given by Dulongs. Means in this formula 1 divided by 100 to calculate the, means here C is nothing but the percentage of carbon, H is nothing but percentage of hydrogen in the fuel, O is nothing but percentage of hydrogen, S is nothing but percentage of sulfur in the fuel. Means these three elements, these three substances only, it will contribute to the calorific value of any combustible substance, means any fuel. So the approximate calorific value of fuel can be determined by knowing the amount of constituent present, means gross or higher calorific value from the elemental constituent of the fuel. Hydrogen, the maximum calorific value 34,500 kilocalorie per gram, carbon 8,080 kilocalorie per gram, sulfur 2,240 kilocalorie per gram. This is the constant value of hydrogen, carbon and sulfur. If in the fuel oxygen is present, is assumed to be present as a water, means fixed hydrogen, means the how much amount of hydrogen available for the combustion of the fuel is equal to total amount of hydrogen minus fixed hydrogen. Total hydrogen is nothing but total amount of hydrogen present in that fuel minus 1 divided by 8 moles of hydrogen in the fuel. Means if the oxygen is present, means the 1 mole of oxygen is required, 1 mole of oxygen is required 2 moles of hydrogen. Means the 1 gram of hydrogen is fixed to that 8 gram of oxygen, it will form water. Means 1 divided by 8 moles of oxygen minus the total amount of hydrogen is that the amount of hydrogen is available for that combustion. So that in that formula 34,500 into hydrogen minus oxygen divided by 8, this. So that where hydrogen, so that carbon, hydrogen, oxygen, sulfur are the percentage of carbon, hydrogen, oxygen and sulfur in the fuel. Oxygen is assumed to be present in the combination with hydrogen as a water. Means the lower calorific value is equal to higher calorific value minus 0.09 into H into 587. Therefore 1 part of hydrogen gives 9 part of water, and then latent heat of steam is 587. One of the example on burning 0.83 gram of solid fuel in a bomb calorimeter, the temperature of 3,500 grams of water was increased from 26.5 degree to 29.2 degree Celsius. Water equivalent of calorimeter and the latent heat of steam are 385 and 587 kilocalorie per gram respectively. If the fuel contains 0.7% hydrogen, calculate the higher calorific value. and lower calorific value means HCV and NCV. HCV is equal to a formula we know, capital W small w, capital W small w, T2 minus T1. Capital W means the water equivalent, the amount of water in a calorimeter. Small w means the water equivalent, 3500 gram and 385 grams. T2 rise in temperature 29.2, 26.5, 26.5 divided by 0.83 grams of fuel has taken. Higher calorific value is equal to 12,638 calorie per gram, and NCV is equal to HCV minus 0.09H formula. Substitute the value, you will get 12,601 calorie per gram. This is to calculate the higher calorific value and lower calorific value. Thank you everyone. Thanks.